Hello everyone, and thanks for your interest in the long version of the video. So you have seen the difference between the QAR-K10 and the QAR-K50 software, which I explained in the short version. I would now like to go a little bit more into technical details and show why the QAR-K50 is there and why this plastic plate is of interest. So when a radar is mounted in the vehicle, it also has a certain field of view. Front-looking radars usually have a field of view of plus minus 10 degrees, and side-looking radars, for example, have a field of view of, for example, plus minus 60 degrees. So when the QAR measures a bumper or a radome, it also has a certain field of view. One cannot say that this measurement method is wrong because it does not only use perpendicular measurement angles. So depending on what one wants to compare, both measurement methods of the QAR are correct. But when we want to compare reflection measurement results with the measurements gotten with vector network analyzers, for example, then we need to reduce the incident angles in order to measure only with perpendicular angles. The QAR-K10 software uses the full panel of the QAR to get the high-resolution image. The QAR-K50 software uses only a reduced part of the panel in order to capture the correct reflectivity measures. When you look at the left-hand side of the slide, you see the standard configuration for the QAR-K10 software. So the distribution of the incident angles is shown on the blue chart. You can see that the typical incident angles is plus minus somewhere between plus minus 40 degrees, which, as mentioned before, usually is not a big problem because the automotive radar sensors have a certain incident angle as well, or have a certain field of view. When we compare these measurements with the measurements taken in material characterization, we are usually taking these measurements with a vector network analyzer. This vector network analyzer uses only one angle for characterization, and that is a perpendicular angle. So therefore, we have reduced the amount of clusters that we are using for this measurement, and we are using only this single cluster. With the single cluster, you can see that the multistatic of the instrument has been drastically reduced. So depending on the intention of the measurement, either the QAR-K10 software or the QAR-K50 software delivers the correct results. So using these two plates, the gray plate and the red plate, I would like to demonstrate how close the results captured with the QAR are to results captured with the VNA and a quasi-optical setup. So these two plates have been characterized using a vector network analyzer. And this plate came up with a reflection value of about minus 7.8 dB, while the red plate came up with a reflection value of minus 28.1 dB. So let's see what the QAR-K50 says to these plates. The QAR-K10 software, which you can see on the left-hand side of the slide, comes up with a reflection value of minus 7.6 dB for the plate. As mentioned, the plate has been tested with a quasi-optical setup to have a reflection of minus 7.9 dB. In this case, the QAR-K50 measurement comes up with a reflection measurement of minus 8.1 dB, which is slightly closer than the QAR-K10 measurement. However, for these huge reflection factors, the difference is not that massive. Let's have a look at the better adapted red sample. Again, the left side shows the measurement taken by the QAR with the K10 software. In this case, you can see that the QAR-K10 software came up with a reflection value of roughly minus 21 dB. This is quite a little bit away from the minus 28 dB that the plate has been characterized with. Looking at the QAR-K50 option on the right-hand side, we can see that the QAR-K50 shows a reflection value of minus 28.4 dB, which is very close to the minus 28.1 dB characterized with the vector network analyzer. So as you can see, it is not really possible to analyze the homogeneity of the plates, but therefore with the QAR-K50 software, it's now possible to precisely characterize the reflection of even low reflective samples, which can be very challenging. You can choose between the QAR-K10 and the QAR-K50 software by a single push of a button in the software. So depending on whether you want to characterize the homogeneity of a plate or its reflection value, either the QAR-K10 software or the QAR-K50 software is the software of your choice. In order to learn more about the technical backgrounds, feel free to visit the QAR area on the Rohde & Schwarz website. Thanks for watching and see you next time.